You are welcome to Separation Process 1 module. My name is Dr. Ola from the University of Greenwich, United Kingdom. Welcome to one of the most interesting modules in chemical engineering. This module, Chem 1134 Separation Process 1, introduces you to the essential role that separation processes play in chemical engineering, where isolating specific components from mixtures is vital for achieving the purity and quality of final products. The principles that guide these processes are crucial as they determine how different substances can be effectively separated. In this module, we shall explore together two main categories of separation processes: mechanical and thermal. Mechanical processes include techniques like filtration, sedimentation, centrifugation, and screening or classification. On the other hand, thermal processes involve methods such as distillation, evaporation, drying, and crystallization. Mastering these fundamental concepts will prepare you for more advanced topics in Separation Process 2, where you'll delve deeper into complex techniques and applications. Understanding these basics is key to developing efficient strategies in the field of chemical engineering. As an introduction to Separation Process 1. Classifications of separation processes. In chemical engineering, separation processes are essential for isolating desired components from mixtures. These processes can be broadly categorized based on the principle or mechanism of separation. Here are the primary categories: mechanical separations, thermal separations, mass transfer separations, membrane separations, electromagnetic separations, chemical separations, and supercritical fluid extraction. Mechanical separations: filtration, separating solids from fluids, whether liquids or gases, by interposing a medium through which only the fluid can pass. Sedimentation, utilizing gravitational forces to separate particles from a suspension. Centrifugation, using centrifugal force to enhance sedimentation or separation of particles. Screening or classification, separating particles based on size using a screen or sieve. Thermal separations. Distillation involves separating components based on differences in boiling points. Evaporation, on the other hand, is about removing a liquid from a solution by boiling off the liquid. Then we have drying, which is simply removing moisture from materials. And finally, crystallization, which is forming solid crystals from a homogeneous solution. Mass transfer separations. Absorption, transferring a substance from a gas phase to a liquid phase. Adsorption, accumulating substances on the surface of a solid. Extraction, separating compounds based on their solubility in different immiscible liquids. Leaching, extracting a substance from a solid by using a liquid solvent. Membrane separations, microfiltration, removing particles in the range of 0.1 to 10 micrometers. Ultrafiltration, separating macromolecules and colloids in the range of 0.01 to 0.1 micrometers. Nanofiltration, separating particles in the range of 1 to 10 nanometers. Reverse osmosis, removing ions and small molecules by forcing a solvent through a semi-permeable membrane. Electromagnetic separations, electrophoresis, using an electric field to separate charged particles. Electrodialysis, using ion-selective membranes and an electric field to separate ions. Magnetic separation, using magnetic fields to separate magnetic materials from non-magnetic ones. Chemical separations, chemical precipitation, forming a solid from a solution by chemical reaction. Ion exchange, exchanging ions between a solid resin and a liquid solution.